So I'll just say the adjacent, and that's going to be 1.73 or 1.77. It's square root of 3. You type that in your calculator and solve for the adjacent, you're going to get that. This is a special case. For a 30, 60, 90 triangle, there's a shortcut. The short side, if they have a ratio of 1 to square root of 3. So basically the hypotenuse is twice as long as this, as the short one, and the medium side is the square root of 3 as long as the short side. So that's the shorthand way to do it. You can always go back, and a lot of times that's not real helpful because this might be 1.7 or something, so it just runs faster to go through it. Another relationship for all these right triangles. Anybody remember that one? A squared and b squared. Pythagorean theorem. I was looking for the name. I couldn't remember it. I'm glad you did. So if we label these as, by nomenclature, you leave this, the hypotenuse as c squared. The other two sides, at a, b, and c, there's a relationship. A squared plus b squared is equal to c squared. Just another relationship. This one we're talking about the lengths. So if I've done this problem right, if I take the length of A, 1 meter squared, plus length of B, square root of 3 meters squared, that should be equal to 2 meters squared. So I've got 1 meters squared plus 3 meters squared is equal to 4 meters squared. That looks like I did the problem right. So whenever you're doing this trigonometry stuff, a lot of times you can actually work the problems a couple different ways. You can use this SOHCAHTOA relationship, and once you get your answers, you can go back and check. You can go back and use the Pythagorean theorem and check the angles. The other thing you can do to check is check to make sure that the sum of the internal angles is equal to 180. Because a lot of times you may work this backwards. Well, let's do a case of that real quick here. Where you're solving for the angles and not for the lengths. So let's do another problem where this one is 2.2, 5.7. We want to figure everything else out. We want to figure out all the angles. We want to figure out all the other length. What's your name?
Brandon.
Brett and Brandon. Okay. Brandon. And let's start. We could start with the Pythagorean theorem. Let's save that for the check, okay?
So are you assuming that that's a right triangle, or
that is a right triangle?
Okay,
so that is right. So we can only use this stuff here on the right triangles.
Or you use sine for the smaller angle because you could use opposite, which is 2.2 over hypotenuse 5.7 to figure out the angle.
Okay, let's look at that. Which angle are we started from?
The smallest one down there.
Down here? Okay. If we use this one, we don't know the angle here?
Yeah. Use the opposite.
Opposite. Okay. I thought, okay. So that's going to work. That's going to give us an angle there, right? Okay. So we've got sine, and let me just call this something, alpha and beta, so we have a name for it. So this is sine alpha is equal to opposite over hypotenuse.